We're going to be debating Grand Canyon and the features of Grand Canyon, so I want to show you what they are. Grand Canyon is 216 miles long, and it starts where the Little Colorado River joins the Colorado River, and it flows through the Kaibab Plateau. It doesn't flow around it, it flows through it. And then Marble Canyon is north of that. That's 61 miles long. And Marble Canyon is way different than Grand Canyon. It's narrower, it's steeper, and it's got side canyons that may be unique in all of the world. And then we've got the same elevation. I encourage people to go into en-us.topographic-map.com. And then wherever you click, you can get the elevation. So you can play around with this, see if I'm doing it right. The river flows into the canyon at 3,100 feet, and then it flows out at 1,200 feet. And yet in the middle, the Kaibab Plateau, it flows through at 8,000 feet above sea level. So it's a mile above the river on the north rim. On the south rim, it's 7,200 feet above sea level. And then you just go around over here, that's 6,000 feet, 4,100 feet, 6,300 feet, 5,500 feet. And then on the north, it's even lower, 4,300 feet, 5,200 feet, and 4,700 feet. And then we have this funnel right here, which is, we'll zoom in on this. This is where Vermilion Cliffs and Echo Cliffs used to be joined at one time. And now this funnel is formed, and it's 18 miles long and it's 12 miles wide. And I took a picture from that direction looking at the cliff. And you'll notice that it's 2,000 feet high, and the layers tend to slope upward toward Grand Canyon. And those white spots on the bottom at the base of the cliff, those are houses. And then this is, if you want to see this picture, go into YouTube and the Brian Nickel channel and check out the origin of Grand Canyon. He's halfway up Echo Cliffs. That's 12 miles over there to Vermilion Cliffs. And those cracks in the middle, one crack is the Marble Canyon, and the other one is one of those barbed canyons. And then if you look up the funnel, that's 12 miles wide. And then to put it in perspective, this is what Grand Canyon would look like. Grand Canyon would be a drop in the bucket compared to that funnel. And then we got potholes on Echo Cliff. And potholes are formed when a rock gets in an eddy or a vortex in fast-flowing water, goes round and round and cuts into the softer sediment. And these potholes are 3,300 feet above the river on a 2,000-foot cliff over 4 miles away from the river. And then we've got barbed canyons. These are very unusual. It's like the tributaries are flowing one way, and then they do a U-turn. You notice here, the big picture here, at the bottom, the elevation is 5,500 feet above sea level, and at the top, it's 4,000 feet above sea level. So the land is sloping to the north, and it drops 1,500 feet. And if you look at the individual canyons, this one drops from 5,500 feet to 5,300 feet, 4,700 feet to 4,500 feet, 4,600, and you get the idea. It's all sloping pretty much towards the north, and yet the Colorado River flows to the south. And then we've got side canyons. These are canyons that are just as deep as the river, and the northern canyons are longer than the southern canyons. And you've got the inner gorge, which is 1,200 feet deep through the hard crystalline rock, and that's a 46-mile gorge. And then you got a block near Isis Temple. It's 5 to 10 tons, and it's been raised up into sedimentary rock. And then you've got layers of sedimentary rock that are bent. And then you've also got a Grand Canyon caverns. They're 63 miles long. If you want to look at them, you got to take an elevator 21 stories down, and they're larger than 3 football fields. And then you've got Red Butte and Cedar Mountain, and these really aren't part of Grand Canyon, but they give a clue of how it happened. Red Butte is 1,000 feet of Mesozoic sediment capped with volcanic rock, and Cedar Mountain is similar, and you can see that from the Desert View Tower. And if you want to answer those, all you need for Grand Canyon is bulging and cracking 3 times. That's the key. 3 bulges, 3 cracks, and that explains Grand Canyon. But to set the stage, you need to have a lot of force to carve the Grand Canyon. Then that comes in the form of 2 huge lakes on the Colorado Plateau. Grand Lake's twice the size of Lake Michigan, and it's at 5,700 feet. So that's a mile in the air. That's tremendous potential energy, and it's incredibly deep. You know, you look at Grand Junction, Colorado, up on the right corner there. It's 1,100 feet deep. A little lower, Farmington, New Mexico, 350 feet deep. And then Page, Arizona would be 1,400 feet deep. This is a huge lake. It's very deep. And Hopi Lake's about the size of Lake Huron. It's 250 feet higher. And those cities would be under 900 to 1,000 feet of water. And then once Grand Lake started to breach and go over Vermilion Cliffs, it cut a slot through there. And then a lot of water is cutting through the slot, so it cut down a little deeper. So you get a whole bunch more water going through, so it cuts even deeper. So now the water's flowing through like a torrent, and that's how you get the potholes to form. And then it cuts the slot down to the hard Kaibab limestone, which is 350 feet thick. It can't go any deeper, so then it spreads out and makes this funnel, and it removes all that sediment. So there's nothing pushing down on the Kaibab limestone, so that bulges and cracks. And then the river flows through that crack and undercuts Hopi Lake. And now you got two lakes that are catastrophically draining, just sheet eroding almost everything off of the Kaibab limestone, except for Cedar Mountain and Red Butte. And then not only does the Kaibab limestone crack, but the whole Kaibab Plateau bulges and cracks. And then the river flows through the crack to carve out the Grand Canyon. But before we get that, let's take a look at the barbed canyons. You know, that when that plateau bulged, now it makes the land slope to the northeast. And that's when the subsurface water flows downhill to the northeast, and then it hits that crack and turns around. And that's how you get the barbed canyons. And you notice here that the river's cutting through below the water table. So now you get a lot of water coming in from each side, and then it's bringing with it a bunch of sediment, and that's how the side canyons form. And you'll notice here it says that the north rim is roughly 1,000 feet higher than the south rim. So that's 1,000 more feet of water to drain out of there. So that's why the northern canyons are longer than the southern canyons. And then the water's gushing through the cliffs, and it carved these caverns 66 miles long. And then it's carving through the Grand Canyon. And again, it's going down, down, down. It hits the hard basement rock of the Grand Canyon. It should have got wider, but it didn't. And the reason it didn't is because now there's nothing pushing down in the Grand Canyon. So the basement rock bulges and cracks. And that's how you get the inner gorge. That's a 46-mile crack in the basement rock. And then how does the National Park System try to explain this? You can see this for yourself. Go into nps.gov, and it says the story of how Grand Canyon came to be, blah, blah, blah. The story begins, blah, blah, blah. So this is a story, folks. This is not science like we think of science. We think of things as that are observable and testable, repeatable, falsifiable, the double-blind type of science. And this is none of that. You know, that's all high confidence science, but what we're doing tonight, that's none of it. It is low confidence science. They call it a story. I'll call it a story. I'd like to call it science fiction. And the heroes of the plot are the Colorado River. Notice this, scientists know that the Colorado River carved the Grand Canyon. Well, how do they know that? Were they there? Did they see it? You know, I'm here to tell you that there's no way that little river cut that canyon 10 miles wide. No way. So that's one of the heroes. The other hero is millions of years. Scientists have estimated an age for the river and thus the canyon through which it flows at 5 to 6 million years. So those are the heroes of the plot. But it actually admits on this national park website, perhaps the biggest question of all, how the Colorado River chose this course and began carving the canyon, still awaits a clear answer. So they don't know how it began. And perhaps the biggest question of all, I would disagree. I think it's, hey, how did this 5 to 10 ton rock get lifted up into sedimentary rock that's supposed to be millions of years old? And then how do these big layers of sedimentary rock bend at a right angle? And it says the Kaibab Plateau, a high point through which the river gingerly slices, poses a problem for geologists. Well, I never saw that when I was at the park. It says, what's the problem? Water certainly doesn't flow uphill. Remember, it flows in at 3,100 feet above sea level. It flows out at 1,200 feet. And yet in between, the canyon rises a mile higher than the river. Rivers don't flow uphill, so that definitely is a problem. I'm glad that they admit it, but it's not very prominent. You got to dig to find it. And it says, while keeping these few accepted chapters in the Colorado River's history book in mind, remember those chapters are the river carved the canyon and millions of years, geologists have proposed a number of different hypotheses. So let's take a look at them. Number one, the Little Colorado River hypotheses. In order for this theory to work, the ancestral Colorado River would have needed to flow eastward over the Continental Divide. Over that. Well, there's no evidence for that, so let's throw that one out. And you got the northwest flowing river hypotheses, and in the red it says, unfortunately, no sedimentary deposits have been found to support this theory. So throw that one out. And then the spillover theory, the catastrophic draining of ancient lakes. Now, that's the one I'm promoting tonight. You know, I agree with them, but they have the lake in the wrong spot. It says the Colorado River was temporarily damp behind the Kaibab Plateau. Well, if that's the case, it would have flowed around the north, which is thousands of feet lower than the middle, which is where the river cuts. So throw this one out. And then you got the collapse of a groundwater karst system. That's where I believe the water's gushing out of the cliffs and eventually it collapses down and makes the canyon. But if that's the case, there wouldn't be potholes on Echo Cliffs. So throw that one out. And so I'm not here to tell you what to think, but I'm showing you where to get information so you can think. And I encourage you to go into creationsciencecenter.org and page 247. And you'll see this for free. It's Walt Brown's 9th edition of In the Beginning. And then you can see all the theories on the top and all the features on the side. And then it's red, yellow, green. Red means, hey, this doesn't work at all. Yellow means maybe it does. And green means, yeah, it sure does. And you look under hydroplate, it's green all the way down. And so we want you to get all the information. You could also go into Real Science Radio, rsr.org, and listen to Grand Canyon Month and see how the river couldn't cut the canyon and how it's not millions of years old. And also you can even listen to Walt Brown explain it. And so again, bulging and cracking 3 times. And I'm just going back to this one. You know, my brother-in-law was in a geology class at a state university, and they spent a week trying to figure out how Grand Canyon formed. And they looked at a bunch of theories, and none of them worked. And then on Friday, the professor said—
1 minute left.
Okay. And Friday, the professor said, you know, there's one theory we haven't talked about. Anybody know what it is? The kid raised his hand and said, no, it's flood. And the professor said, yeah, you're right, but we can't talk about it. You know, isn't that interesting? They don't have a theory, but they won't even discuss that. And to be fair, this is not right after the flood. Things had to solidify so it didn't turn into a big bowl. You know, the Kaibab limestone had to get hard. So I'm proposing that this was a few hundred centuries after the flood. And so to wind it up real quickly, you know, bulging and cracking 3 times. That's how you explain the Grand Canyon. You know, you had 2 huge lakes up there. Once they started draining, they bulged at the funnel and it cracked, and then it undercut Hopi Lake. And then it sheet eroded everything, called the Great Denudation. So then the Kaibab Plateau bulged and cracked. That's the second one. And then it eroded all the way down to the hard basement rock of the Grand Canyon. And so then the basement rock bulged and cracked. And that's how you explain Grand Canyon. And it just makes perfect logical sense. And I hope they'll put this on the National Park website, because the theories that they have there don't work. And they might as well put a theory there that does work. But I think we need more people to shine the light on that. So anyhow, that's the Grand Canyon in 12 minutes, bulging and cracking 3 times. Thank you so much.